In order to find the scale, begin by measuring your vectors. So far, I see that our vector is approximately 7.5 centimeters. That 7.5 centimeters is representing 40 newtons. So in order to get my scale, I'm going to go ahead and do a division like this, where I say 40 newtons is to 7.5 centimeters. I'm going to divide the top and the bottom by 7.5 because I want my number ultimately to be in terms of 1 centimeter. So 40 divided by 7.5 is 5.33. So that at the end I have 1 centimeter is about 5.33 newtons. So that means every 1 centimeter represents 5.33 newtons. So next, what I'm going to go ahead and do is take a look at the rest of these problems. Let's see, use a ruler to determine the scale. Check. 1 centimeter equals 5.33 newtons. Use a ruler and protractor to construct the vector that represents the resultant force. First, I'm going to start by doing my diamond. I'm on the computer, so I'm not drawing as straight as I would like. Use a ruler. Okay. Alright, so I've drawn my diamond, and it looks like my start here is at point P, and all of the vectors agree here. They meet up at this as my end. Red carpet treatment from start to finish. So this is my resultant. So construct a vector that represents the resultant. Check. What is the amount of the resultant force? So now I need to use my ruler again. And I need to measure how much this is. Seems I've run into a problem and I can't rotate my ruler. But because this is at 90 degrees, and I have both the horizontal and the vertical, I can also do Pythagorean theorem to find out the amount of my resultant. So I'm going to do a squared plus b squared equals c squared. And I'm going to do 40 newtons squared plus 20 newtons squared to get c squared. So after some calculation, I got that 44.7 newtons is my resultant. Now, actually I can use this number to find out how many centimeters long is my resultant. So I'm going to do what I was going to do with my scale. So with my scale, I had 1 centimeter is equal to 5.33 newtons. And I have that my vector is 44.7 newtons. Match up n with n. And I can go ahead and solve for x by cross multiplying. So I'm going to end up with 5.33 x equals 44.7 n times 1 cm. And it looks like I'm going to go ahead and divide by 5.33 n. 5.33 n cancels my n's. And all that's left is x is 8.94. So my resultant also has a measurement of 8.94 cm. That represents 44.7 newtons. Okay, next we're going to go ahead and have to measure the angle between east. So let's see, east is this one, and my resultant, this one. So I'm looking for this angle right here. What you'll notice is I don't have a protractor, so I can actually use some trig. I know that to make my resultant, I had to use twin vectors, so that this vector is also 20 newtons, and this one is 40 newtons. And if my angle is this one, this is my opposite side, this is my adjacent side, I could use inverse tangent. Oops, I copied it wrong. Inverse tangent of opposite over adjacent is going to give me my angle. When I plug things in, I get an angle of 26.6 degrees. So that's how much this is. Alright guys, so whenever we're looking at a problem like this, we're being asked which one of these vectors is the vector that will add to A to give us the resultant that we see up there. Which one of these is the correct B? So let's go ahead and start. What I'm going to do is I'm going to take my A vector and I'm going to just add it to all of these other vectors and see which one it makes the most sense with. You can put it like this too. So I've done the same thing with all of the vectors, so I set them all up here next to A. And right now it doesn't tell me much. So I have to go ahead and do my diamond shape. Remember that each vector is going to have a twin vector that's the same length, same angle, and points in the same direction. So let's see, that's my vector B for that one. I think this one's supposed to be blue. This next one's supposed to go this way because they're identical twins. So they have to point. Whoop, whoop, whoop. That's not a twin. He's way too tall. Supposed to be like approximately the same length, same direction, same everything. Okay, let's go ahead and draw our twin vector A's. Maybe it looks like that blue one, I drew it too long. Okay, my A vector is in the same size, same angle, same everything that my first A was. You'll notice it's also the same as that A right there. Alright, now I'm going to look for where my vectors are tail to tail, head to head. Tail to tail is where everything starts. That's where I start my walking path. Okay, so let's see. Here's the start. Here's tail to tail. Here's tail to tail. Here's tail to tail. Now, if I wanted to walk along this path, for example, I could walk this way and then that way, end up right there. I could walk this way, then that way, end up right there. So this is my end. So this is the resultant like that. Okay, that one's too long, so it's not that one. If this is my start, everyone agrees to meet up here. My resultant goes this. You'll see that I could start walking like this, turn over here, I could go like this, end up right there. So this is my resultant in the middle like this. He's pointing down, so it's definitely not this one. Let's take a look at this vector C, which is in orange. Tail to tail is right here, so that's where I start. Head to head is right here, so I'm going to go like this. That one looks pretty good. Looks like a pretty good match. And so you'll notice that it's 3 walking paths. I can walk like this and end up there. I can walk like this and end up over there. Okay? And then, of course, my shortcut. Let's just take a look at the purple one just to be safe. So tail to tail is right here. So that means I start walking, I end up here. Start walking, end up here. So that's the meetup spot. Okay, so that means we start walking here, we end there, that's our shortcut, and that's definitely way too long. So that shows that C is definitely our answer choice. And you basically do that for all of the vectors. It's easier to do, I think, on a computer where you can move things around, but eventually it's good for you to practice also with the ruler, because this does pop up on the long answer response in the back of the test. Okay?